Good day, welcome back to the channel. In today's video I've got the Deye inverter. It's a 5 kilowatt inverter. This is the IP66 inverter. It's one of the strong inverter in the market, so it was damaged by lightning. So let's see what's going on, what we can do to sort out this inverter. Let's switch on the inverter and see what's happening. Okay, I've got the power connected. You can see the inverter is coming on, the lights are on, and the LCD is coming on. Okay, let's see what alarm are we getting there. Okay, you can see that it's showing the off on the screen. There is the alarm COM fault. So what is COM fault? So COM fault, it means that there's no communication between the LCD and the main board or the control board. So there's no communication because this LCD, it can come on, but it still needs to communicate with the main board. So there's no communication between the main board and the LCD. So the problem could be the main board or the control board. We are going to open it up and see what we can do to sort out this inverter. But right now I'm going to open it. Okay, I took out all of the screws underneath the heatsink. You can see here the screws. We have to take out all of those screws all over there. Then we're gonna turn the inverter upside down. Okay, you can see that now the inverter, it's a little bit loose. You can see when I open there, now it's opening because all of those screws are now out. Okay, so now what we have to do is to take out the connection board. This is the connection board. We have to take out this board. So here is all of the screws that we took out underneath. Now we have to okay, you can see our connection board is loose now. So the next thing, we have to take out these PV cables. So firstly we have to take out the earth. Okay, our earth cable is out now. So now we're gonna take out the PV cables that are connected inside there. So we have to like move it up. So there is the PV cables. So we have to remove all of these cables because they are going to that switch there. You see those PV cables? We have to take them out. Okay, we can now take out this communication board out. There is the board, it's out now. So what we need to do now is to disconnect the LCD. Okay. So we have to take out these cables for the LCD. LCD is out. Okay, now remove the other cable for the comms. Okay, there we are. We've got the inverter open. We can now remove the main board. So to remove the main board, we have to first remove this generator board and remove the fan, remove the capacitor board, remove the control. I've already disconnected the control board. This has to come out, and then we can remove the control board. So here is our control board. This is the main brain of the inverter. So we have to remove this whole main board, but just like I've explained, we have to remove these other parts. I'm going to do that now. Okay, here's our capacitor board. It's out. Okay, I remove all of those screws. So with Deye we have to be careful. It has got lots of screws, so we have to take care of these screws because we're gonna need them at the end. Okay, let's take out this cover so that it will be out of our way. So we have to remove this. This is the switch. So now we can take out the cover. Now let's take out the generator board. Now we can clip this board, this connection. Okay, there. Okay, now we have to let's remove this bus bars. Got 3 bus bars, the fuse, and the current sensor. This one senses the current that's been pulled from the battery. So to remove this board, this is where the problem is. So we have to remove all of these screws, and if you look on the MOSFETs there, all of those MOSFETs, they've got screws, and also there's screws on these black bars there. Okay, you can see all of those screws. We have to remove them. And there on the IGBTs, there are some screws. You can see that screw next to this cable there. We have to remove all of those screws, all of those. Then we can be able to take out this main board. Okay, now the board is loose. We have to take out these temperature sensors. There's 2 of them. So we have to be careful. These screws are still in. You can see all of those screws. We have to make sure that we don't lose the screws. Okay. Okay. I took out all of the screws and they are now safe. Here is our main board. Okay, I've got the board on the table now, so it's gonna be easier for us to test the board and see what's the problem and what you can do to repair this board. So just to give you a brief explanation on this board. So here you've got your MOSFETs. These are your low voltage MOSFETs. They change the DC voltage. You can see that they are connected to the DC bus bar there. So this is your connection, battery connection. So these MOSFETs, they change the 48 volts to 400 volts. So that 400 volts go to these IGBTs. So this 1, 2, 3, 4, these are your output IGBTs. So you also have the active rectifier here, these two IGBTs and the diodes, and you also have the 4 IGBTs. These are your PV. So this is what you need to do now to check all of the MOSFET and IGBTs. So I've got my meter on a diode test. I'm going to test all of the MOSFET, the red pin there, 0.4, 0.4, 0.4. So I've tested all of the IGBTs and MOSFET. There's no short circuit, they look okay. So we have to check the other side of the board to see what could be wrong. Okay, as you have seen, we've just finished checking all of the transistors. We've checked the IGBTs, the solar panels IGBTs. We have checked the output IGBTs and the active rectifier. We have checked the DC MOSFETs. All of those transistors are okay. So the next thing now that we need to check is the control board and the power supply. So let's start with the power supply. Remember, we've got the 48 volts coming in here. We've got this switch mode power supply. This is the switch mode power supply that's going to step down the voltage, the 48 volts to 5 volts, 12 volts, and minus 12 volts. So on this switch mode power supply, next to it there are some 2 LEDs. So we have to check if those LEDs come on. So what I will do, obviously I need to connect the switch. You can see this cable here, it's coming from the switch on the inverter there, on the outer case. So I just took out the plug there, and the other end comes in here. So this is the switch that turns on the inverter. So on the pin out here, we've got four pins on the plug here. So the 2 middle pins are for the light, and the other 2 pins are for the contact. So when you switch on the switch, these 2 contacts will close. So we are just going to do that now. We're going to close the contacts. We are going to close these contacts here. See these contacts? Let's close them. Okay. So you can see that I've closed the contact. It's just the same as the inverter has been switched on, so that we can be able to check all of the voltages. So now let's connect the DC power and see how it works. So this is your ground and this is your battery plus. So remember, we took out the bus bar here. So don't connect it on the other points, just connect on the first point. These are your ground bus bar. So we're going to connect the ground and the battery positive on BAT1. BAT1, see it's written BAT1 there. So we have to connect our 48 volts there. The inverter should come on. Yes, you can see the LEDs there, they are on. So when I take out these two contacts, it's going to go off. You see? So these two contacts are for the switch. You can see now it's on there. Okay, we have just checked the switch mode power supply. It looks like it's okay. You saw the LEDs were coming on there. So now we have to check all of the voltages to make sure that they are there, because on the control board we've got different voltages. As I've mentioned, I'm going to show you the points. Okay, you can see on the control card there we've got different voltages. We've got 12 volts, we've got 5 volts, minus 12 volts. Those are the three most important voltages that we need to check. So I will have to check that although the lights are coming on, and also there are some LEDs on the control board, those LEDs needs to come on. See those LEDs there? They have to come on. We have to make sure that those LEDs, they come on. Because if the LEDs are not coming on, then there will be no communication between the display and the main board, the control board. So those are the other LEDs. These LEDs need to come on. Okay, now we can connect the card. Okay, let's connect the power. Okay, we do have the light underneath, but the LEDs on the control board are not coming on, which means that we're missing a voltage. You can see there, underneath is blue, but on the control card we've got no light there. So those are the LEDs that need to come on. So let's measure. Okay, let's measure. This is our ground point. This is our ground point, and this is plus 5 volts. We've got 0.7 volts. That's not good. So let's check the other voltages. Okay, this is our plus 12 volts and our ground. Yeah, 12 volts is there. You can see 11.98. We do have the 12 volts. Let's check our minus 12 volts. There's no minus 12 volts. Oh, there is. So the contact was not good. So there is minus 11 volts, and there we've got 12 volts, and here there's a 5 volts which is missing. Got 0.7 volts. Okay, so why do we have that? So the problem it's on a 5 volts rail. So it means that this control board, it's a problem. The control board is our problem, because we do have the 12 volts and the minus 12 volts. So the 5 volts must be shorted somewhere. Let's measure the resistance between the 5 volts and the ground. Okay, before we measure the resistance, we have to make sure that there's no power. We disconnect the power. Let's measure between the 5 volts and the ground, the resistance. Yeah, it's dead short. Dead short. So I've got dead short on these 2 points. Let's disconnect this cable. Just trying to isolate now. Let's measure again. 5 volts and ground. Dead short. See, the cable is out. Let's take out the other cable. See, both cables are out now. Okay, now I'm going to test the card alone without any connection. You can see this is just a card. It's not connected to anything. So let's check the resistance again between the 5 volts and the ground. We have 40 ohms, but you can see that the resistance has now increased. Let's connect the cable. Okay, let's check again. 5 volts and ground. We've got 0 ohm. So, which means we've got 2 problems here. The control board has got a short because it's 40 ohms, and also the main board, because once you connect it, it goes to 0 ohms. So we have to find out why are we getting that 0 ohms on a 5 volt rail. So we have to look at that and check until we find the problem. Okay, so what I will do now is to check this main board, because we are getting a 0 ohm between 5 volts and ground once we connect this cable here. So it means that something on the main board there is not right, it's shorted. So what are we going to do now is to check the components around the circuit, or the switch mode power supply circuit. Okay, here is our switch mode power supply. So what we need to do now is to check all of these components around this switch mode power supply. Let's use the ohms meter to check the capacitors and see if there's no short circuit. Let's check here. There we've got some kilo ohm on the capacitor. There's mega ohms. .8. There, you see that capacitor here? I'm getting a 0 ohms. So this capacitor is giving a problem. So I'm not supposed to get a 0 ohms there. I should get a little bit of resistance. So this is the capacitor that's giving us problem. This one. You can see when I measure there, I'm getting a 0 ohm resistance. So what I'll do, I will remove the control chip. If the short is still there, then it could be the capacitor itself. Let's remove the chip. Let's check the resistance now. We still have a 0 ohm. Let's take out this capacitor. So we are still having that 0 ohms. So what we need to do now is to supply power here, and then we can be able to see what's pulling the power. It's gonna heat up, then we can find out where is the problem, because we are still getting the short circuit here. After removing those two most important components, let's see if there's any other component that we can remove. It looks okay. Okay, let's check the diodes. Okay, maybe this diode. Let's check out this diode. Okay, the diode is okay. Okay, you've seen what I did there. I removed this IC, removed the diode, removed the capacitor, the large capacitor there, but we still have a short circuit there. So what I will do, I will inject power on this capacitor, and then whatever is shorted, it's gonna give us a sign by heating up. So that's what we need to do now. So we inject 5 volts here, because this is a 5 volt rail, and see what's going to heat up. Okay, I've just connected the solder there. I'm gonna connect the 5 volts, then we can see what's happening here. This is our negative, because we don't want to swap the polarity. Negative and positive. Okay, we are pulling 5 amps there. So what's going to heat up here? see, I have to check all of the components. Something must heat up. Something must heat up. Something must heat up. Ah, there's a smoke there. Let me zoom in, then you can see. See that 5 volts, it made us to discover the... There, you see this component here. It's heating up. You can see the smoke coming out there. So we injected that 5 volts then it gave us the indication where is the problem. So this optocoupler is not right. So let's remove it. Let's disconnect the 5 volts. Okay, this is the optocoupler. Let's see. Okay, I'm gonna now move back to the capacitor. Let's see if we still have the short circuit. So this is the point where we injected our 5 volts. Okay, let's check now the resistance. Yeah, there's lots of things damaged here. We still have a short. Let's inject until we get out of, get rid of all the bad components. This is our ground. We're going to inject our 5 volts again. Okay, yeah, we're still having 5 amps. Okay, there must be something left. Okay, the second one is heating up. The second optocoupler. It means that it's better we take out all of these optocouplers, because this other one is also heating up. Let's connect power again. I think we are sorted now. We are pulling 0.9 amps. Let's check with the multimeter. The same capacitor again. Yes, you can see now we've got 500 ohms. That's good. That's good. So our 0 ohms is gone. Now our 5 volts rail on the main board is now open. Okay, so this is the capacitor that was giving us 0 ohm resistance, which is the 5 volts rail. So now if I measure here, because we took out those optocouplers, they were heating up, we've got 500 ohms. That's okay. That's good. So we are going to change all of those optocouplers. But now the next step is to switch on the board and see if we do have the 5 volts across this capacitor. Let's connect the 48 volts and switch on the inverter and see if we do have that voltage. Okay, let's connect the power. Okay, we now have 3 LEDs that are on. So let's measure between the capacitor So I'm going to measure across this capacitor, which was giving us a short. Check out the voltage there. You can see I have 5 volts there. So our 5 volts is okay. So the board looks like it's okay now. So what I will do, I will get another control board, and then we can move further. Okay, we are now done with the main board repairs. We've got our 5 volts okay, and then the MOSFET and IGBTs, they were okay. So now we can assemble the inverter back together, and then we can try and test it and see what's happening. So that's what I'm gonna do now. I'm gonna put back the board on back to the heatsink, and also connect all the cabling that's attached to this inverter, and then we can try and run it and hope for the best. Let's do that now. Okay, I've just connected all of the boards that we are supposed to connect before testing. I've connected the capacitor board, the generator board, and the control board. Also the LCD is connected. So you remember our initial problem was that the LCD was showing the comms error. So there was no communication between the LCD and the control board. That is because the 5 volts was not coming to the board. Obviously, if there's no 5 volts, the CPU won't work. If the CPU is not working, the LCD will get the power, because on the LCD we have a 12 volts. You see this connection here is the 12 volts that supplies power to the LCD. So the LCD will get power, the CPU will work for the LCD, but what's going to happen is that this cable here, you see this white cable, this is for the communication. It's going to this point here on the control board. See, it's coming here. So the LCD will be trying to communicate with the CPU, but it's not getting any signals from the CPU. So you're going to get that comms alarm. So what's the cause? Main board was not okay, 5 volts was not there, and also if your control board is not right, you will get that comms fault. So it's either the main board or the comms card, which is the control card, or both of them. So in this case, both of them were having a problem. You remember the board was having a short and the control board was having a short as well. So here is the old control board. So I've realized that all of those op amps there, I've removed all of them. So they were shorted, all of them. So that's why we're getting the short on the 5 volts rail. So we have to test it. Let's see what's going to happen here. Let's test it. Okay, our LCD is coming on. So our LCD is now trying to communicate with the main board. You can see we've got the comms. That alarm was there permanently. It's trying to come. Yeah, you see now there's a communication. You can see now it's saying on. It's on now. So the inverter is now communicating. So one of the things that you need to check if the inverter is giving a comms failure is the LEDs. So these LEDs have to come on. If these LEDs are not on, it means that the control board is not working and there will be no communication between the LCD and the main board. So in this case, we repaired the main board and also changed the control card, and we've got the on signal there. We are going to test everything, and then we can close this inverter. Thank you very much, and thank you for watching, and I hope to see you on the next video.